Welcome! In the world of cybersecurity, the very first move you make, it's not an attack, it's not some complex exploit. Nope, it's just a look. Today, we're going to dive into reconnaissance, the art of truly seeing your target long before they have any idea you're even there. I mean, think about it. It's the most basic question, right? You can't just stumble up to some digital fortress and start banging on the walls hoping you find a weak spot. You got to know what you're up against first. Is this thing made of brick? Is it just drywall? Are there any windows at all? And that right there is exactly what reconnaissance, or as most people call it, recon, is all about. It is the art of gathering information before you even think about launching an attack. So, for today, think of yourself less like a burglar and more like an architect. You are meticulously, carefully creating a detailed blueprint of the entire system. And trust me, that blueprint, it's the key to everything. Okay, let's start building that blueprint. The very first thing any architect needs to know is the foundation. What's this building actually made of? Well, in our world, that foundation is the operating system. We have to figure out what system is actually running the whole show. And what's so wild is how this one piece of information completely changes your game plan. A tool like Nmap can often just tell you what the OS is. So if it comes back and says, hey, this is a Windows server, your brain immediately snaps to weaknesses in things like Remote Desktop Protocol, or RDP. You start thinking about its Active Directory, which is kind of like the network's digital phone book. But what if it says it's Linux? Well, now you're playing a whole different sport. Your entire strategy pivots. You're now thinking about SSH, different user structures, and all the common exploits you find in open source software. Just knowing the OS gives you a completely different playbook to work from. And just like that, with one simple piece of information, we've gone from a totally blank page to drawing the foundational outlines of our building. The blueprint has officially begun. So, we know what the building is made of. What's next? Well, now we need to find the doors and windows. In part 2, we're looking at what software is actually exposed, all the services running on that machine that are open and listening to the outside world. This is the perfect illustration of the logical path, really. It's like a chain of discovery. First, your scan finds an open port, and hey, there's a web server running on it. Interesting. Next, you kind of politely ask that server, so what version are you? And it might just tell you, oh, I'm Apache version 2.4.53. Now that number, that tiny seemingly insignificant detail, that's the golden ticket. Because now you can take that exact version number and check it against public databases of known exploits. And if you get lucky, you find a match, a publicly documented vulnerability. You haven't just found a window, you found a window with a broken lock. And this quote just drives the point home, doesn't it? It's why you hear security pros talk nonstop about patching and updating. It is so easy to install some little plugin and just forget about it for years. But for an attacker, that one tiny, forgotten, outdated piece of software, it might as well be a giant, glowing weak spot. It's the one single thread that can unravel everything else. All right, so we've looked at the building's foundation, and we've checked its doors and windows. Now it's time to actually go inside and start scouting the web application itself. We're moving from the network layer up to the application layer. And for this kind of work, the industry standard, the Bible really, is the OWASP framework. Okay, this is where our blueprint gets incredibly detailed. We are no longer just looking at the outside of the building. We are inside, and we're mapping every single room. We're trying to figure out the web framework. We're sifting through public code repositories for any secret somebody might have left behind. We're hunting for hidden files, mapping out every single API endpoint, and even triggering errors on purpose just to see if they leak some juicy information. This is a top-to-bottom internal inspection. You see, each one of these little findings adds another critical layer to our blueprint. Now we're sketching the internal wiring, the plumbing, the specific layout of every single room. We're starting to understand not just what the application is, but how it actually thinks. So we have all these individual notes, right? The OS, the software versions, the application details. It's a pile of puzzle pieces. Now it's time for the final, most important step, building the attack map. This is where we assemble all of our recon data into one single cohesive picture. And here it is, the final product. Our blueprint is finally complete, and just look at how it all comes together. We know the OS is a specific version of Linux, which immediately points to known kernel exploits. The web server, an Apache version with a known misconfiguration. Oh, and this is a classic. We found an outdated WordPress plugin that is publicly available exploit code you could find with a quick search. And to top it all off, we even found an API endpoint that doesn't have proper security. The path forward is now crystal clear. So just think about what we've actually done here. We started by staring at a total digital black box. And now? Now we have a complete architectural drawing with big red circles highlighting all the structural weaknesses. That is the incredible power of systematic reconnaissance. And this brings us to the final and maybe the most important question. This blueprint we've built is an incredibly powerful tool. A defender, a blue teamer, uses it to create a priority list for fixing all these flaws. But an attacker, they use this exact same document as a roadmap for an intrusion. The techniques themselves are totally neutral. It's the intent behind them that's everything. How this blueprint gets used, well, that's the choice that really matters. Thanks for tuning in.